So I spend a lot of time listening to podcasts, but I also spend a lot of time just looking for podcasts to listen to. When podcasters go from a chess grandmaster to the former CTO of Coinbase to Kanye West within 3 episodes, it's easy to get lost in the mix. I was tired of endlessly scrolling, just trying to find the right podcast, that I decided to create a program to do it automatically. With the click of a button, this program can look through all of your favorite podcasts, scan through all of their episodes, pick out the ones you'll find most interesting, download them, transcribe them, and save everything locally. In this video, we'll learn how to create such a program. We'll also learn about surrounding technologies like natural language processing, web scraping, and much, much more. The goal of this video is not to just create a useful program, but also to build a text corpora that we'll use in future videos for a data science research project. Should be a lot of fun. Shout out to AssemblyAI for sponsoring this video. AssemblyAI is a leader in speech-to-text transcription, and they have a very Python-friendly API that we'll use a bunch later on in this video. All right, before we can write a program to download podcasts, we need to know a bit more about how podcasts work, how they're hosted and broadcasted across the internet. So to start off, just find whatever your favorite podcast is on, Google Podcasts, Apple Podcasts, whatever. So I'll go to Google Podcasts, and we see a bunch of podcasts right here. I'll give some shout outs to some of the podcasts that I listen to. So 2 of the podcasts that I've been listening the most to recently, one is the Huberman Lab. Stanford neuroscientist, does all sorts of really informative podcasts on basically taking science and applying it to your day-to-day life to kind of improve your sleep, improve your focus, all sorts of just science hacks, I would say, and tricks to optimize science for your own physical and mental health. A lot of great stuff. I've also been listening a lot to the Lex Fridman podcast. He does a lot of good tech and science interviews. You can learn from a lot of very smart people with his podcast. So let's dive into this podcast. Okay, so we see all of the available episodes here. And in order to download something, we need to have some sort of link, some sort of MP3 file that we can, take and download these files. If we go to Google Podcasts, if we go to Apple Podcasts, they all have this same feed of episodes. And where that is coming from is what's called a RSS feed, so real-time simple syndication, that stands for. And basically, it's a kind of more universal way to broadcast out, if you have a podcast, all your different episodes is kind of a one-stop shop where if you have the link to the RSS feed, you can get all of the information about the episodes. So what does the RSS feed look like? Well, we can take this URL, we can go to a site called getrssfeed.com, and we can go ahead and paste that into the site. And what we'll get out is we get the Lex Fridman podcast right here. And what we really want to do is click on this RSS feed button. And we get now a fun XML file that has all of the information for all of the episodes that Lex Fridman has put out. Now, just a little bit of an aside, if you're curious how getrssfeed.com is doing this and getting this XML file, well, you could do a little bit of handy-dandy web scraping inspection. So if I was to inspect this web page here, I'll make this a little bigger so we can see more. But if I was to inspect this web page and I was to kind of just scroll through and try to figure out how it's getting all these episodes, one thing that you'll stumble upon is what's called the data feed. So we actually see that the RSS feed is linked right here. And if you look at anyone's podcast, you'll find a similar data feed parameter within the HTML of the podcast.google.com site, and this is where the RSS feed is. So you could skip that step with getrss.com if you had a little bit of web scraping intuition. Cool. So we know where that came from. Now, what can we do with this podcast feed? And I will make this a bit bigger so you can all see this. And let's, for the heck of it, make this full screen. So we got a lot of fun stuff here. So first off, we see we have this channel tag. We see we have like the Lex Friedman podcast and all sorts of stuff. We have a little bit of information about the podcast. And then if we keep going down, we'll see that we start getting into what is known as these items. And so items contain the actual information about a podcast episode. So you can look through all of this to find out about the podcast episode. And one thing that's pretty important that we'll use later on is that we get a description about the podcast. We can grab the title of the podcast. But probably the most useful thing here for us trying to web scrape and download these podcasts automatically is that if we go, it's kind of hard to find, but if we go down a bit further, let's see. We keep scrolling down. We get all sorts of stuff in the description. Okay, we got it. If we go down here, we see this tag called enclosure. And within the enclosure, one thing that we get access to is this MP3 file. So we can go ahead, copy this link, paste that in to another
The following is a conversation with Fiona,
browser.
a presidential advisor and foreign
And look at
policy
that.
expert.
We now have a URL. I'm talking over. Hey, Lex.
Bush, Obama, and Trump.
We now have a URL that points directly to the MP3 file where our podcast is coming from. Now this is super cool and super helpful. So now if we can programmatically find this enclosure URL, we can automatically download podcasts. But something that's even more useful is now we not only can do that, but we also can use the rest of this RSS feed information, and we can programmatically go through it and just find URLs for episodes that we're most interested in, because there's tons of information in this RSS feed. Okay, so let's start writing some good old Python code. If you want to not have to write everything from scratch and you just want the source code, you can go to github.com. Oh, I'm super zoomed in right now. You can go to my GitHub, github.com/Keith Galli, and I will link this in the description. I have a repo called Podcast Downloader, and you can go there for all sorts of information on what this will look like, how to kind of set up the code. But if you want to start from scratch and just learn how to do this all together, see the full kind of project experience, then what I recommend that you do is open up a fresh Jupyter notebook. So I will navigate to any old repo. So I will go to my home directory, go to a file called YouTube code, and I'll just make a directory called podcasts or something like that. Whatever you want to name it to make it descriptive for yourself. Okay, I'm going to cd into podcasts, and then I'm going to go ahead and look at that directory. There's nothing in it right now. I'm going to just open up good old Jupyter notebook. And we have the Jupyter notebook. Open that up. New Python 3 kernel. And let's do some Python code. All right, so what does this look like? Well, if we think about the process that we used, kind of just going through this ourselves, well, we first found the RSS feed. So it's going to be important to have the RSS feed URL somewhere here. So I should go ahead and paste that. Oh, that's the episode URL. So the RSS feed was this right here. So we have an RSS feed URL, and what can we now do with this? Well, I think what we want to do is we have the URL, but we now actually want to get the HTML or the XML content into our Jupyter Notebook. So we can do that with a combination of Beautiful Soup. So I'm going to create a cell above. This is just going to be importing the libraries that we need for this. So it's going to be Beautiful Soup, from BS4. And if you don't have Beautiful Soup in your terminal, or actually just through the Jupyter Notebook, you can do a pip install Beautiful Soup 4. We see we already have it. I also want you to do a pip install requests. We already have that too, but we're going to import both of those libraries. If you're not familiar with how to use requests in Beautiful Soup, I've made a tutorial going through all of the basics of web scraping, and that will be popped up right here, I think. So go check that out. It's super, super useful library to know about. So we have these two libraries. Let's import them. And now let's go ahead and get the content. So I'll just call this page equals requests.get. We want to get the RSS feed URL, and we can just check to see if this works by doing print page. We see we get 200 response. It's a success. Within the request library, we can do .content. And that should give us the actual stuff that we want. Look at that. That's the XML code. So next, we want to create our Beautiful Soup object. And that's going to be soup equals Beautiful Soup. And paste in, what a fun name that library is. Beautiful Soup, page.content. And because this is an XML page, not HTML, we do want to specify that it's XML. So we will pass in XML over here as a second argument. Look at the Beautiful Soup documentation if you're not familiar with what I'm talking about, or watch the tutorial that I mentioned. One quick note is you might get an error when you try to use XML here. You also need to have installed the LXML library with Python, and we see that we have that too. So XML, run that, and now we have our Beautiful Soup object. So if I just printed out soup, we see all the stuff in that web page that we were looking at. So that's pretty cool. And Beautiful Soup makes it super easy for us to actually look through all of this content. So we will go ahead and we will do let's start with a find all, and we'll find all of the items because that's where the actual episodes are contained. Look at that. So I can call this like items, or I could call it podcast items. Podcast items. Okay, so let's just look at the first item in this list. That is the most recent episode released as of making this video. And so let's say we wanted to get the description out of this. We could do podcast items. Now we have a new kind of smaller Beautiful Soup object that we're working with. We could do .find description, let's say. See what that gives us. We see we just get the description here. And then one useful thing we can do as well is if we wanted to get rid of the actual tag stuff, we could do .text. And then we just get the description of the episode. Cool, but we didn't want the description. We want to actually download this. So how would we download this? We could, instead of finding the description, we want to find that enclosure tag. So enclosure. Let's see what's in there. Look at that. We have a nice little tag that has the URL in it. And so if you want to access one of these keywords, so like if you wanted to access type or length, what you can do is pass it in using brackets. So Beautiful Soup makes it very easy for us to access properties within the tag. So length would be like this. We want the URL. So we can do this. Cool, we have a URL now. And so let's expand this and let's start downloading these URLs. So what would that look like? I think it's good to start with just one URL. So we have our URL here. We could do another, so MP3, we'll call this MP3 file equals MP3 URL equals this, MP3 file equals requests.get MP3 URL. And then we basically want to save this somewhere. So we're getting the URL where the MP3 file resides. How do we actually download it? So I would go ahead, you can do a good old Google search. And let's do download MP3 file with Python. Go to this link, look through what they list here. This first answer looks pretty good. So we can do the request that we just did. And then we see we can simply do something like this. f.write doc.content. Paste all of this in. My file.mp3, write buffer is f, doc.content. So this in our case is mp3 file.content. This indenting seems a little bit far. Okay, that looks good to me. So what happens if we run this? mp3 file, moment of truth. All right, we have something here. Let's see if it worked. Okay, we see my file.mp3 in our browser. So I'm going to just quickly open that up. See if we actually can hear it. So we saved it in YouTube code, podcasts, my file.mp3. So cross your fingers that this downloaded.
The following is a conversation with Fiona Hill, a presidential advisor and foreign policy expert specializing in Russia. She has served the Bush, Obama, and Trump administrations.
Cool. So it downloaded the podcast. And that was pretty simple. That was, like 10 lines of Python code. Let's expand on this. Let's make this better. So we just downloaded one podcast. Let's convert this, let's download, let's say 10 podcasts and maybe put them in a specific directory that, is organized. So to do that, we have all of our podcast items here. So let's I'm gonna probably delete some of this code and clean it up, but let's look at the first podcast item again. What? Podcasts items. All right. So we see this information. We got the URL last time, but I think it's also useful to have the title. So let's do something. So let's do for podcast in podcast items, title equals podcast.find title .text, and then the URL, we can copy and paste this code that we used last time. Just to make this neat, I'm going to delete this code after I've copied it. mp3 URL equals podcast item. So in this case, it's just podcast.find enclosure URL. And then we want to download it. So we can follow this and paste that in as well. Okay, that looks good. And now what we want to do is we want to download, let's say 10. So I'm going to limit this to 10. So we'll make a little variable called count equals 0. If count equals 10, we'll break out of this. And what we'll do is at the end of each iteration, we'll do count plus equals 1. So now what do we want to do? Well, we don't want every file to be saved with myfile.mp3. So what we're going to go ahead and do is make a downloads directory and then save it as something like, we'll use an f string so that we can pass in a variable directly to this. We'll do title.mp3. That should be good. So now it has, each file will have its own title. I think that's all we need to do. Let's run this. Cross our fingers that it works. No such file or directory downloads. Okay, so it's complaining to us because we don't actually have a downloads directory. So you could do this either manually or you could do it with Python. I'll do it with Python. We can import another library called OS, run that cell again. We do os.makedir, I think that's it, makedir, makeDirs, downloads. Let's see if this runs. Oh, it ran. Okay, so we should have it now. Run this again. And it's going to take a second, so I'll probably just edit this out as it runs. You could also like throw a print statement in here somewhere so you could see the title as it's downloading it. Okay, it finished running. So moment of truth is, do we have all of these episodes locally? Okay, before we just had myfile.mp3. Now we see we have a downloads directory. Look at that. It looks like it downloaded the last 10. And you could play around with how it names the title. We just took it directly from the RSS feed. But if I clicked on like fellow YouTuber Gotham Chess.
The following is a conversation with Levi Rosman, also known as Gotham Chess.
We got it.
Professional chess player.
We could, click on another one.
The following is a conversation with Balaji Srinivasan, an angel investor, tech founder, philosopher, and author of The Network State.
Cool. So we downloaded 10 podcasts super quickly with Python. Now let's take this and see how we can expand on it. Let's see how we can search for specific episodes, and let's see how we can transcribe these episodes so we have even more to work with. We could be even more, fancy with how we search and decide to star podcasts that we might like, and go from there. So to do this, let's import another library, and this is going to be the regex library, so RE for regex. I talk about this a little bit in my natural language processing video, and I hope to do more tutorials on regular expressions soon. Super powerful tool in Python and in other programming languages. Okay, we have the regex library now. So what we're going to do is I'm going to temporarily not download any episodes. So we'll just kind of comment all of this out briefly. And what can we do? Well, we could do like some if conditions based on what the title is, what the description is, etc. So let's say if re.search and this is going to be like the term that we're looking for. So with like Lex Friedman, all sorts of episodes across the board. Let's say I'm curious specifically about robotics. So robot, I'm going to pass in, let's say maybe the description. So description equals podcast.find description.text. So if it's in the description, and we can also pass in flags. So I'm going to pass in re.I, which stands for ignore case. So regex.search for the word robot in the description, and we're going to ignore the case. Print, let's say, title. All right, let's try this real quick. And let's only increase our count now if we do find one with robot. Run this. Look at that. So we see already in the title here, there's robots. Rodney Brooks, literally his episode's called Robotics. Russ Tedrick, under actuated robotics. So we get a bunch of different things here. One of the cool things about regexes is we could do all sorts of fancy stuff here. We could make a regex to look for multiple words. So maybe I wanted robot, I wanted artificial intelligence. I could do all sorts of things that I could search for. I could also look for AI, but that's a tough thing to look for because if I did AI, I would do every one of these episodes will have AI, the letters AI, in a sequence next to each other. So let's run this real quick. Yeah, we see that like we get most of the most recent episodes because AI is such a common thing. But if I did \B AI, \B, that means word break. So now it's going to just look for AI by itself without other letters around it. And we can specify this as like a regex string with R. So here we would get much cleaner stuff related to AI, and we see like the Tesla AI former head. We see other AI ones immediately. We could print out the description if we wanted to kind of confirm that AI is there. I think that might be helpful. Yeah, we see AI in that one. All right, I'm going to delete all of that. The point is that you can, add multiple words. You could do anything you could do with regular expressions here in a search function, and then you could only add the episodes and only add the URLs that you wanted to download. So like we could put all of this stuff in here. We could put, the URL in here and only download, the podcasts that have robotics in it. One useful tool is regex checker, like doing, you can use something like regex101.com. So if you tried a regular expression like AI, right, and you tested pain and air, I don't know, and actually just AI is cool. Like it's gonna match, I think, all of these. Oh, and then you ignored case. Like that would match both. But if you did something like that followed by a word boundary, we see only AI matches. So you could play around with this, make it work how you want it to work. That was a bit of an aside, but definitely useful. So I'm going to quickly just go ahead and show how you would download. So maybe we did something like, you could say output equals something in brackets. If you find that it does work, then you get the URL, and maybe so this would be pretty good. That wasn't actually needed. So let's quickly just set our limit to 5, how about? and we can go ahead, look at our downloads here. I'm going to just delete all of these real quick. I just want episodes that have robot somewhere in the description. And I will run this. Does that work? It should work. Okay, it ran. Let's see what we got. And yeah, we got 5 episodes. And I think if you expanded this and really looked at their titles, you'll probably see robotics in a lot of their titles. But regardless, you should be able to kind of tell that they're probably going to be episodes that mention robotics, and you could check the RSS feed to confirm. Cool. It's definitely super useful. All right, with that, we know how to download podcasts as well as add a filter and download specific podcasts. Next, let's see how we can take these podcasts that we downloaded and transcribe them. And a quick note is that basically one extension you can already do here is, let's say you wanted to look through 5 different podcasts for specific episodes that mentioned a topic. So something that is interesting to me right now is improving my cardiovascular health. So I might look up some fitness podcasters and specifically search the term, fitness podcasters or doctors, let's say, and specifically look for, with a regex, terms like zone 2 cardio, zone 3 cardio, endurance training. I could look at all of that and search all of their RSS feeds and just get the episodes that are most interesting. So something useful to know about is if you just made this a list of RSS feed URLs, you can do a lot with it, and I'll show that moving forward. But now let's go ahead and transcribe some podcasts. So to do this, we will be using our sponsor for this video's API, AssemblyAI. So to get started with AssemblyAI, you can go to assemblyai.com. There's a bit of variance here. You can access the API for free, but if you really wanted to transcribe tons of podcasts, it probably would start costing you. You can go ahead and click on Get Started, and you can create an account here with your email and password. I'll just fill in my details quick and create account. I already have an account, so I could just do the sign in process. And so once you've upgraded once you've signed in, then you are presented with a console. One of the things that I'd recommend to understand what the API has available is to use the no code option to start. So you could just kind of go in here and upload one of those files. So if I go to YouTube code, podcast downloader, podcasts, and go to downloads, and then click on one of those. You can very easily and visually see what is possible. So I might transcribe only the first 2 minutes just to see what's here. You can pick out what you want to include in your transcription. And really, I use this sandbox just as an idea to know what I want to include in the API when I reference and get this and do this using the API. So it's a good starting point. So I'm going to run that real quick. First needs to upload the podcast episode, the MP3. I think you can also do this with MP4 files. And then I think it takes 15 to 30% of the podcast time, like the MP3 file time, to do the transcription. So if it's a 10-minute podcast, then it'd be 1 to 3 minutes for the transcription. I forget if that number is perfectly right, but that's a good frame of reference. So if you're transcribing a 3-hour podcast, it's going to be, now I'm trying to do math quickly in my head, 27 to 54. Yeah, 27 to 54-ish minutes. Okay, so while that's being transcribed, we can go ahead and revisit our code and start interacting with this API programmatically. So what would that look like? Let's go back to the AssemblyAI console. Okay, so we have this API key here. I'm going to click to copy that. And then we could start just immediately, using that key. But the biggest thing here is I don't want to paste this in. I don't want everyone to see my API key. So like API key equals, some random string of characters. What we instead want to do is use what's known as environment variables. So we have the OS library that allows us to access environment variables, but basically instead of passing this as raw text, what's better to do is to get that API key through our system environment variables. I think it's like this. So I might save it as something like AssemblyAI key. And there's different ways to set these environment variables. It depends on your operating system. I'll put a link here on kind of a comprehensive for all operating systems solution. But if you're using Windows, you might go up here to edit the system environment variables. Click on that. So I just hit the Windows key, and then I searched, and then I typed environment variables. That's how I found this little panel that is now open. I would click on environment variables, and then I have a bunch of blurred out things over here that you can see. And basically I would add a new variable, call it like assembly AI key, paste in the value, and that's what I would use overall. So I'd save all of that. Then you'd actually have to restart your Jupyter Notebook just so it could load in that new variable. So that's one last detail to know if you aren't having it registering. So once you've added your API key as a environment variables, we could run this, and then you can proceed. I'm not going to print this fully out because I don't want you to see my API key, but I could print out, let's say, like the first 3 characters and confirm that that looks right. So as long as that matches up with what you see in your console, and look at that, it does match up, then you're good. And as we were doing that, our transcription finished up. So cool thing here is, this is a nice visual way to see everything that you have access to within the world of the sandbox. So I can, zoom in on this and really see what's here. We see the full transcript. We also see that you could automatically do stuff with AssemblyAI, like get out, important phrases and words and get a sense of, what this is about. This could maybe be used in a more sophisticated search functionality. You have some topic detection, also potentially used in search functionality, and you have some auto chapters. Note, we only did this with like the first 2 minutes or something like that. So this is not everything, but you could use the sandbox for all things. Very, very useful stuff, and this all can be accessed programmatically as well. So good to know. But let's actually start, messing with the API. So going into the console here, I'm going to go to the API Quick Start. And there's a lot of useful stuff here. I'm going to kind of just walk you through, but note that this resource is here if you need it. I'm going to start with uploading. And so basically, to transcribe, you need an accessible web URL to the file that you want to transcribe. You could probably pass in the MP3 file directly to the transcript function because it takes in a audio URL. I was running into some issues with some of the podcast files, so this might not be a full solution. So just to have a solution that will work regardless of where the MP3 file is, I'm going to use the upload functionality first. So what does this look like? We see some information about the functionality, and then we see a nice little function over here that actually shows us how to do this. And it's nice, you can set this to whatever type of code that you're using. So we are going to be caring about Python, but you could also do like JavaScript or PHP, Python. So we'll do Python. We could honestly just copy all of this code to our Jupyter Notebook. I'm going to paste this in, and now we can start filling in our variables. So in this situation, our path to our file could be just anything in the downloads folder. So we'll keep that in mind. So yeah, let's do this with the entire downloads folder. So I'm going to say files equals downloads. And then we'll basically read each of the files and post each of the files. So I also want to move this to the next line. Okay, so what is this going to look like? We have this nice read file function that they gave us. So we'll just use that, assume it works. We could paste our API token right here, but let's do the smarter approach and paste in the environment variable that is our API key. Then the data is just the read file, and what we'll do is we'll do a little for loop. So do for file in files. And we know it's in the downloads folder, so we can get file names by doing os.list directory of the downloads. And I'm doing a lot right now, but it will make sense in a second. We could quickly, actually let's do this outside of the loop. File names equals os.list directory downloads, and let's just see what that gives us. I'm gonna comment this stuff out quickly. What happened? I'm also going to delete this real quick. Okay, so those are the file names. That looks good. And now basically what we want to do is we want to paste in the file name here, but we need a path to the file. So I'll just call this file path. That's just going to equal downloads / going to pass in the file here. And that should be good because we see in the files when we're printing this out, it has the .mp3 extension. So file path, that looks good. And now we can uncomment this. Put this in here. You could also, move the headers. The headers stay the same no matter what. So you can move the headers outside the for loop if you want to. We'll clean up all of this code later on in the video, or at least I'll show what cleaned up versions of this code looks like. And let's go ahead and post these files. And then basically once we upload them to AssemblyAI, we can transcribe them there too. It might be worthwhile to print out the response of the JSON, so we can do that. We can leave the print statement in just to know that it's working on a specific file. We've already imported the requests library, so you could go ahead and clean this a bit. Like I like having my functions in separate cells, typically. So let's try this. Let's see if we upload them to AssemblyAI successfully. And we didn't. File name is not defined. Oh, it's file path. Okay, so we're working on uploading that first file. And one thing you could do is you could do like print uploading ... or just uploading and then comma the file. So that would be a little bit more descriptive of a way to put this. Okay, so we see our first file was uploaded. I'm going to just copy this URL and we'll paste it in a new cell. And we'll just keep letting that run behind the scenes. All right, so let's keep looking at the API. We've now uploaded a file. The next step would be to transcribe it. And what we'll see is if we go down a bit, there's a create a transcript little blurb. This gives us all sorts of useful information about how to create a transcript. Again, all of this nice Python code is here, so I will leverage that. But the biggest thing basically is that we need an audio URL. We need a place that we're transcribing the audio from. Another thing that I will say is important is that we do probably want to do an audio start from and an audio end at to limit how much we transcribe. with AssemblyAI, you're going to be charged based on the transcription length. So like when you're testing things, I highly recommend confirming things work and keeping this a very small range. Note it's in milliseconds. So 1,000 milliseconds is 1 second. So keep that in mind when you're doing this as well. So let's put all these factors together. Okay. I'm going to paste all of this in. And so our audio URL now, we'll just do one file to start with. Paste this in. Okay, that looks good. Again, our authorization is os.environ assembly AI key. In our JSON, we want to pass in a couple other variables, so we don't want to transcribe everything. So we'll do audio start from and audio end at. I think those were the two variables we wanted. Let's just confirm. Audio start from, yep, audio end at. That looks good. Let's make sure that's formatted correctly. We need a comma after the first parameter. Audio start from. Let's start it at, let's say, like the 5-minute mark. So 5 minutes in terms of milliseconds would be 60, or 1,000 milliseconds is a second. 60 seconds is a minute. So 5 minutes would be 60 times 1,000, or sorry. 5 minutes would be 300 seconds, so 300,000 milliseconds would be the 5-minute mark. Let's say we wanted to end at the 10-minute mark, that'd be 600,000 in milliseconds. So we can pass in all those, clean this up, and that should transcribe one of our podcasts, just part of it. And with the free version of AssemblyAI, I think you're limited to 3 hours of transcription. So this also helps us not run up against that free aspect. Run. Status queued. Okay, that seems good. If we kept printing out that response.json, I bet you would see it change in a second. I guess we'd have to run the request again with the ID. And so if we now go to the console, what we should see is hopefully in this bottom left area, our first actual piece of information here. Or maybe we can go to developers, usage. Do we have anything in there yet? Developers, processing queue. Queued, processing. Okay, look at that. Our file is getting transcribed, and basically, eventually it will be completed. And the key thing that we want here is this ID. This will help us retrieve our transcription. So I'm going to copy that. And what we could do is do the final component of the kind of transcript component, which is retrieve a transcript. And what we need for this is to pass in a unique identifier. Let's see if there's some sample code here. Get a transcript, cool. And I want the Python version. Oh, you don't have a Python version. I'll show you how to do the Python version. So let's now get our transcript. Let's get that URL. It's going to be transcript to the ID. You see the .id here at the end, or the colon ID. So paste that. So this is our endpoint. Now we can paste in that ID that we saw. And then let's see what else we need to do. We probably need our headers still, our authorization, yep. So this is going to be pretty similar to our other requests though. I'm just going to copy some of this information too. Oh, we don't need to keep importing the requests. We'll edit this as needed. Okay, so our endpoint now is /ID. So I'm going to just take this, paste it here. And now there's no JSON that we need to pass in because we're just trying to retrieve what's encoded, what's transcribed. So we can delete all that. We can delete this from here. The moment of truth is, can we get the information we want back? Well, let's see if it's done. It might be still processing. Yep. So still processing, but we could see what happens if we try to retrieve it now. Make sure you have your commas. Okay, so something's happening here. I think I actually do need that colon maybe. What do we do? Do we mess up the... What's going on? What's going on? What did we do wrong? Was this our full ID? I think it was. Oh, okay, here's our issue. This was kind of a silly thing. We need to do a GET request, not a POST. Just the different types of functionality that we can do with the API. So this should actually have been a GET request. And now we should be able to not just get an error here. Look at that, cool. So do a quick sanity check. Is this done processing? It might be still processing. Okay, but we'll probably see that here. So we'll see status somewhere in here. And if you want to make it easier, we could do this on a new line. Response.json. Okay, much easier to follow now. If we look at status, I bet you we still see it processing. Status processing, cool. So once that's actually done, we'll see the text thing fill out, and that's our transcript. Cool, completed. We run this again, so we see status is processing. Oh, I guess we actually, we need to do the get again. We run this again, and we see it's a lot more information, so I bet you, yeah. Now we can grab response.json.text, and this is the transcription. And cool. It looks like we still got a little bit of the ad reads at the start, but you can play around with that. In the console, we will see we have one transcription now, and you can always access your transcriptions by looking at like usage, or looking at the processing queue and just looking at the completed or the processing. Great, so we know how to transcribe a podcast as well. And why is this important? Well, there's multiple goals you could have with a project like this. One might be just to download podcasts that you might find interesting, but another is kind of the goal of this research project, and that is to create a text corpora out of this. So how could we, basically we need to just now scale this to transcribe full podcasts for a bunch of different podcasts, and then we have a nice corpora that we could use. And the research project that we're doing is we're researching the language of tech, and we have a bunch of tech podcasts on one side, and we're using this as kind of the balancing point. We want to have tech podcasts, non-tech podcasts, and see what we can learn about language from both of these sides of the equation. All right, so let's clean this up. I'm not happy with how much information is here. Okay, so to clean this up, there's multiple ways you could do it. I like creating functions out of things. So like I might make def transcribe podcast or something like that. You could play around with this. But I think one thing we want to do too is just be able to, immediately go through a process where we download, transcribe, or download, upload to AssemblyAI, transcribe on AssemblyAI, and then, download those transcriptions or something like that. So what that would look like? Well, we upload it here, but basically if we wait till it's done uploading, then we could immediately transcribe it. So let's just paste this code into the for loop. We can pull out the headers. So I'm going to just put the headers towards the top of the, doesn't need to be in the for loop. I'm going to just delete this one. I don't think the content type should matter at all for this first function. So it's fine that we have extra information in it. Let's see. Our audio URL now, though, is going to be the response.json upload URL. Because as we see what we were printing out before, there's an upload URL parameter, and if we just take that, we can immediately transcribe it. So if we run this code right here, it should now transcribe all 5 of those podcasts. We're going to redo the one that we already did, but that's fine. I just want to show this for example. So we'll let that run. And then, so I can go ahead and now delete all of this because we have it elsewhere. And then we want to get our podcasts. The thing is, processing takes a decent amount of time. So what we could do here is we could do a little bit of a hacky type little trick here. Is we could do while true, and maybe we would want to save all of the IDs after they're transcribed. So I might just pause this real quick. What do we get after we send a transcription or try to create a transcription? One of the things we get is the ID back here. So what we'll do real quick is I'm going to just grab the output IDs, dot append response.json ID. And then basically we can pass those IDs immediately into the code over here to actually get the transcript. Run. Now what we want to do is for ID, or let's say transcript ID, so transcript ID and output IDs, our endpoint is going to be whatever the transcript ID is here. Our headers, and the headers kind of remain the same. So honestly, they'd be saved from above, so we can kind of just ignore the headers right now. This is already saved in a variable. Response.get. And then what we can do is we can look at the status. Basically, if it's processing or queued or just not running, then we keep the while loop going. And I'm going to actually put this while loop in here. I'm going to say while true. status. I'm doing a lot here, but it will make sense in a second. Status equals response.json status, and basically if status equals completed, we can exit out of this for loop. So should be able to do break, and that will exit out of the while loop, but it will stay in this loop. And maybe we say got transcript. And to prove that we got the transcript, it'd probably be good to write the text to a file or something. So we might do with open transcripts. Transcript transcript ID / or .txt to get that transcript. That's writing as f.write response.json text. So that will save the transcript text. And there's a lot of code here. Basically, I recommend trying to break this up into simpler functions, and I'll show that in a second. If you didn't enter that for loop, basically what we want to say is print couldn't retrieve transcript, try again in 3 minutes or something like that. And then we can do we can import the time library, and we could do something like time.sleep of 180 seconds. And that would rerun then this while loop 180 seconds from now. So we see that we've uploaded all of these. If we look at our processing, is there anything found here? Yeah, it's processing a couple podcasts. Let's run this code while it's doing that so you can see how it works. Couldn't retrieve transcript. So 3 minutes will go by and we'll see this run again. And then hopefully it outputs the transcripts. I see an error that we're going to run into if we're not careful. Basically, we want to make sure that we have a transcripts folder here. Before I created this I created the downloads folder with the OS directory. This time we will create transcripts with just manually, the old-fashioned way. And so just to make this clear, the purpose of this while loop is that it takes a while sometimes for the transcripts to process. So it's like basically one way you could approach this is you could run this, upload all of these transcriptions for processing, and then come back to your code in 3 hours or something if they're really long podcasts, and run the script that basically gets all those transcripts. The reason you'd use this while loop is basically it's annoying when you have to come back to your code at a certain time to run the next set in the function. So this would keep the program going in the meantime, so it could immediately kind of grab within a 3-minute window the podcast when it's done. So it looks like it's still not done processing. I mean, there's a lot of transcripts here processing, so that makes sense. And you could make this a little bit more clear if you, let's say, printed out transcription ID, then you could kind of in the background check, what it's looking for over here on this side. Cool. Look at that. So basically, it was waiting on probably one of the latest IDs to process. So once that one finished, basically all the other ones were completed. So it went through this for loop and pretty easily get all these other transcripts. Let's see if they saved properly. Transcripts. Look at that. So it's id.txt. I would recommend modifying this code to give it a nice, neat name. So probably use the same podcast title, maybe, within the txt file that you save. We don't get a ton of information from this because we're only transcribing 5 minutes, but you could extend this. You could basically just, change up, where are the values? You could just, remove these values from the JSON when you're transcribing, and that would let you transcribe everything, but there will be a cost associated with that if you do it for enough. You get 3 hours on the free trial. Cool. And that's basically it. What we're going to do next in this video is just show how we could take this and just make it much neater. So I'll show some kind of more streamlined code that I put together using this as a baseline. All right, so to kind of tie this all together is basically when I write code and when I'm creating a Python program, I typically like to start with a Jupyter notebook like we did. But once I'm confident and comfortable with what I have in the Jupyter notebook, I'll then move all of that code in the Jupyter notebook to some Python scripts. It's easier to run all of the Python scripts, at once versus it's annoying when you have a Jupyter notebook and you have to just go cell by cell, running each one for your program to execute. So the goal is to clean up code and to make it easy to run everything at once in the Python script world. So what does that look like? So you can see all of the finalized, cleaned up code by going to github.com/KeithGalli/podcast downloader. And, once you've cloned that, you can also look through the README and whatnot. But if you've cloned this code locally, you can kind of go through this code and see how it's working. I'll open up Sublime Text to show it on my side. Open up the folder, podcast downloader, select folder. Okay, so what does the code look like? Well, we can start with the podcast class. So basically one thing that I think is helpful when you're creating programs is to use classes effectively. So maybe actually let's start with the downloading of podcasts and we'll see how this podcast class can help clean things up. But basically, imagine we have this loop of code. Basically, it can go through all of the podcasts. So let's say you have multiple podcasters that you like to listen to. So I could quickly modify this to include something like this. So basically you can add any podcast that you'd want to get podcasts for, episodes for. So I could add another podcast here by doing the following. Paste in the name that you want it to save as, so a directory or something that would create, and then the RSS feed URL, same thing with the Tim Ferriss one I just added. Basically, we have that. And then what we want to do is we iterate through each podcast in the podcast list. So we have 2 podcasts in this list, and we can call on the individual podcasts. So on Lex Friedman, for example, we can do podcast.searchItems. And so that's a class method on a podcast. And so that gives us advantages. Is basically we can have built-in class methods and kind of clean up a lot of the code and kind of isolate it to one specific area. But we can call this search items. We can look for robots, and then we can limit it to just 5 results. If we then look at the podcast class, basically when you create a podcast, when you pass in that name, so Lex Friedman, RSS feed URL. So that's, we're doing that right here with this object. Then it also does some extra helpful things. So at the same time as calling that, it creates a download directory for you. So you never have to worry about your files not getting saved or it giving you an error when it tries to download them to a specific spot. And it also gives you a transcription directory for the same reason. You can use these URLs at any time you're referencing the podcast. So if you're working with 10 different podcasts, each podcast has its .download directory and .transcription directory to keep them all separate. So this was a nice little thing that made it a little bit neater and easier to separate. You could have a simple get function, which basically takes that RSS feed URL, gets the text as a beautiful soup object, and then just grabs all of the podcast episodes, the most recent ones, up to some limit. Or you could do the more fancy thing where you search through all of the episodes, and you only get it if it matches your regex, regular expression search term, and then you could also pass a limit here, so it limits 5. And we go back down here, you can do that, so you get all the episodes. You could also get metadata for all the episodes, so the titles, the descriptions, the publish date. That could be potentially useful if you want to just get the most recent ones, or you want all of the podcasts in October. You can leverage the pub date field from the RSS feed. Definitely useful. You could add your own custom functions, like simplifying a title. It's one thing that I saw that caused errors sometimes was if there's random characters. Imagine you have a exclamation point or all sorts of weird characters in the title. If you had a slash in the title, definitely would cause issues, because when you try to save the title, if it's AI/ML engineer in the title, then that slash, when you try to save it locally as a transcription or something, it's going to try to nest 2 directories deep, if that makes sense. I'll type that out. So if you had in your title Keith Galli AI/ML engineer, then if I try to save a title like this, then it's going to create a directory right at this split. So you want to be careful when you're saving certain things. It's you can do your own little fancy title functionality. You could add that in. Then it's basically just getting the MP3 file. We've seen that before. It's creating a variable to save it, and you can just directly call the download directory here, the podcast.download directory. So very straightforward to download, just neater, easier code, and you could expand it for however many podcasts you want to download for. Then the other aspect of this is the transcriptions. So we have that's not right. We have a transcriptions.py object, and basically that's just taking all the AssemblyAI code and then adding some additional functions to just make it simpler. So that upload to AssemblyAI that we were doing in our Jupyter notebook, let's just make that a function. And you just have to take a file path for your local file. And it does everything else, it takes care of the rest. So it makes it a little bit neater, easier to read. You can also take the transcription function and just pass that in. One neat little thing is we used keyword args here so that you could pass in the same variables that you can pass in to the API requests on AssemblyAI. You could pass them into this custom-built local Python function. We see the same read file function that we were using before. You could add a little bit of metadata or something. So if you you've already transcribed a podcast, you could save it in such a way, you save a little metadata. So I'll go and open what that metadata looks like. You could save it in such a way where you have a title, and that maps to the transcription ID of that title. So what that's useful for is you don't have to retranscribe something you've already transcribed. So it's useful to maybe save stuff like that. Let's see what else we have here in the extract transcriptions. You could also then save the transcriptions locally. We kind of did that at the end. We can reference the podcast.transcription directory. If we go to transcripts, we see we have multiple directories of where they're being saved. And that little function that we did, that we waited until it was completed, that can be leveraged where you have one function that just gets the AssemblyAI transcript, and then we have another function that basically is okay, if we can't get the AssemblyAI transcript, if it's not completed, or if we get an error, then it lets us know that, and if not, it just tries again in 5 minutes. Useful stuff. And then let's look at what this looks like all together. basically you could take all of the podcasts and podcast lists. So let's say you've already downloaded the files for Lex Friedman. By just running this code, it knows where to look for this named podcast. It already has a download directory associated with that by creating this podcast object, because podcast encapsulate all of that information. If we look at the source code for podcasts, you pass in the name, you pass in the URL, well, it creates that download directory automatically if it doesn't exist. But if it already exists, then we just have that saved. So if we've already downloaded podcasts for someone, then it's nice because we can reference the way that we describe that, down here, and already have like the download directory associated with this podcast. It just makes it less moving parts. Things are a little bit more set in stone. And as you can see, we can pass in all of those different variables that we have access to within the AssemblyAI API directly through this create transcripts method, because that takes those keyword arguments and it passes them through to the transcribe podcast function. So no matter how many keyword arguments you add, it'll pass them all through to this transcribe podcast function. And then what we can see is basically it creates the JSON that we remember from the API reference. So if we go to the API reference, there's all of this JSON here, and we have all of these different variables we could pass in to that, a lot of useful stuff. And what it's doing here in the Sublime Text code, it's just basically packaging them all up into that JSON, no matter how many things that you put in, and then it's sending it to AssemblyAI. So it's a nice little trick that could make it easier to access the different things you might want to pass in through a Pythonic way. It's kind of a bit of a wrapper over what AssemblyAI offers. And that's basically it. The one last thing I did to tie this together is I like clicking one button and downloading and transcribing. So I created a bash or a shell script that just basically runs download podcast.py and then transcriptions.py. And ultimately, to create this a text corpora out of this is we just use a bunch of different podcasts. Maybe we pass in 50 different podcasts and we get 50 episodes for each one, and we just run that through this script, and it will do all the work for us. We just have to sit back and wait. So hopefully this was a cool project. Hopefully it was fun to see how this worked, and hopefully it kind of makes sense how we'll use this in the context of a larger research project. If you have any questions, let me know in the comments. Also, if you want to add on your own project extensions, that'd be great for portfolio purposes. I think a couple things I would think would be super cool would be one, right now we're manually adding the podcasts we like, but could you create an extension of this that could find podcasts you might be interested automatically and pull them into the downloading and transcription process? That would be one portfolio project. Another possible portfolio project is that we typically don't download and listen to podcasts on our PC. Maybe you do, but I like to listen in Spotify. Spotify has its own API. So one thing that'd be really cool is you could use this type of tool to mark the podcasts you'd be most interested in, and then maybe write a Spotify extension that could automatically add them to your Spotify library on your phone. Your good old cellular device. That would be super, super cool. There's other possibilities. You could build on and be much more creative with the search functionality. You could use NLP techniques like word vectors, or even get really fancy with BERT or GPT-2 or 3, and do some creative semantic search type stuff where, let's say, it didn't talk about robots, but it talked about automated assistants. If you could create an NLP script to automatically match automated assistants with robots, you could do fancy search stuff like that to capture a broader space of what you might be interested in. If you do build off of this project, I would love to know. Let me know on Instagram, let me know on Twitter, and I'll happily reshare your work as long as I see it. All right, if you enjoyed this video, give it a big thumbs up. If you want to see more videos like this, make sure to click that subscribe button. Shout out to AssemblyAI for sponsoring this video. We're going to do some really cool stuff with the transcriptions we create from AssemblyAI, so I'm really excited for future videos. Until next time, everyone, peace out.